All right, let's talk about one of the most important and sometimes, let's be honest, one of the most confusing parts of Kubernetes, networking. We're going to look at how Kubernetes took a really messy manual system and turned it into this simple, powerful model that completely changed the game for how our applications talk to each other. So let's get into it.
To really appreciate what Kubernetes did here, you first have to understand just how broken things were before. Container networking used to be a massive headache. If you just wanted to get two containers on different servers to talk to each other, it involved all these complex manual workarounds. It was not fun.
And this slide, wow, it just lays it all out. On the left, you've got the old way, this tangled web of manual port mapping and something called network address translation, or NAT. It was a constant source of problems. But then, look at the right. That's the Kubernetes model. It's clean, it's simple, it's flat. Every single piece of your app gets its own unique network identity.
So let's actually dig into that nightmare a little bit more. The real problem, the core issue, was that containers, by default, all shared their host machine's IP address. And that single fact created a ton of downstream problems for anyone trying to run real, distributed applications at any kind of scale.
This right here, this captures the pain perfectly. We used to call it port management hell. You try to run two web servers on the same machine, right? And boom, they'd immediately collide over the same port. So you had to go in, manually reconfigure one of them, then hunt down every single service that talked to it and update them too. It wasn't just annoying, it made automation and service discovery, how services find each other, incredibly fragile.
And this brings us to the absolutely elegant solution that Kubernetes brought to the table. Instead of having us fight over ports on a shared IP, Kubernetes introduced a radically simple idea. Just give every single workload its very own unique IP address.
And that's the IP per pod model. A pod, which is the smallest thing you can deploy in Kubernetes, gets its very own IP. It doesn't share it with the host, it doesn't share it with any other pod. And just like that, containers started behaving like the virtual machines and physical servers that we were all used to. Networking became intuitive again.
This quote right here, it nails the strategic genius of the model. By giving each pod its own IP, Kubernetes completely separates the application from the physical machine it happens to be running on. Your app can get moved anywhere in the cluster, and its network identity, its IP address, stays exactly the same. That is the very foundation of cloud-native portability. And the benefits that come from this are just huge. Port conflicts? Gone. Service discovery? It's now as simple as just looking up an IP address. You can take older legacy applications and just lift and shift them into containers without rewriting all their networking code. And maybe most importantly, it makes communication between all your microservices, that's what we call east-west traffic, so much cleaner.
Now, to make this whole philosophy work everywhere, in any cloud and any data center, Kubernetes laid down a few non-negotiable laws. You can think of these as the fundamental physics of how the Kubernetes network operates.
Okay, rule number one is the big one. Every pod has to be able to talk to every other pod directly, using its real IP address. No hiding addresses, no translation in the middle. This is what creates that single, flat network space across the entire cluster, and it's absolutely essential for distributed systems.
Rule number 2 is all about making sure the control plane can actually do its job. The node itself, the host machine, has to be able to talk directly to the pods it's running. This is for things like health checks and monitoring, and you don't want any networking magic getting in the way of that.
And Rule 3 is all about transparency. Basically, what a pod thinks its IP address is what everyone else in the cluster thinks its IP is. This simple rule prevents all sorts of bizarre bugs in applications that might, say, share their IP address with other services, like a database telling its peers where to find it.
So here's the really clever part. Kubernetes defines what the network has to do with these rules, but it doesn't actually implement the networking itself. No. Instead, it created this brilliant specification that lets any network vendor plug their own solution right into the cluster.
This standard is called the Container Network Interface, or CNI. And honestly, the best way to think about CNI is to picture a USB port. It's a standard interface that decouples the main system, in this case Kubernetes, from the peripheral device that's going to do all the actual work.
And if we build on that analogy, Kubernetes gives you the port. That's the CNI spec. Then the network vendors come along and provide all the USB devices. These are the plugins you've heard of like Calico, Flannel, or Cilium.
And as the person running the cluster, you just get to pick the plugin with the features you need, whether that's raw performance, extra security, or just simplicity, and you plug it in.
And the whole process is really straightforward. When a new pod is ready to start, the system makes a call to whatever CNI plugin you've chosen. That plugin then does all the heavy lifting. It creates the virtual network card for the pod, it assigns that super important IP address, and it sets up all the routes so it can talk to the rest of the cluster.
So these CNI plugins, they generally use one of two main strategies to actually move the packets between your nodes. And these are known as overlay and underlay networking.
Here's the high-level view. An overlay creates a virtual network that sits right on top of your existing physical network. An underlay, on the other hand, actually teaches your physical network how to find all the pods directly. And as you can imagine, each approach has its own set of trade-offs. Overlay networks are super popular because they're easy. They just work pretty much anywhere. They basically wrap up the pod's network traffic inside another packet. Think of it like putting a letter inside another, bigger envelope. The physical network just delivers the outer envelope. It doesn't need to know or care what's inside. The only downside is a tiny performance hit from that extra wrapping, which we call encapsulation overhead.
Underlay networks, on the other hand, are all about maximum performance. They use routing protocols like BGP, and each node basically tells the physical network routers, hey, here's exactly how to reach all of my pods. There's no wrapping, no extra envelope, so it's incredibly fast. The catch? You need to have administrative control over your network hardware to make this work.
And this choice between overlay and underlay is a really key differentiator between CNI plugins. You can see here, Flannel is a classic example of a simple, easy-to-use overlay. Calico is famous for its high-performance underlay that uses BGP. And then you've got these newer plugins like Cilium, which can actually do both and uses some amazing new tech called eBPF to push performance even further.
So, after all that, what is the big takeaway here? What's the real genius behind the Kubernetes networking model? I mean, why did it become the industry standard? While the absolute genius of this model is its perfect separation of concerns. On one side, it gives developers exactly what they want, a simple, flat network where everything just has an IP address, no complexity. And on the other side, it gives infrastructure operators what they need, a flexible, pluggable system where they can choose the exact right tool for their specific performance and security requirements.
And that leaves us with one final thought. If Kubernetes made networking so wonderfully simple for all the applications running on top of it, where did all that complexity actually go? Because it didn't just vanish. It was abstracted away, hidden inside that powerful, pluggable CNI layer. And understanding that layer, well, that's the real key to mastering Kubernetes.